Given a region R, we want to find a transformation that maps S onto R. Now remember, R is a region in the xy plane, and we want the sides of S to be parallel to the U and V axes. And we have a description of the region R. But I want to point out that if our region S is parallel to the U and V axes, then we're looking for constant limits for U and V. Now to make sure that we know what we're looking at, let's go ahead and graph the four curves given by R, which are y equals 1 over x, y equals 4 over x, y equals x, and y equals 4x. So here are our four curves. We have y equals 1 over x in blue, y equals 4 over x in green, y equals x in purple, and y equals 4x in orange. The region R is bounded by these curves, and so is that region there. Now what we're after is a transformation that maps some region S, which is in the UV plane, onto R. First, what we need to do is make sense of these four equations. And it takes a little bit of trial and error, but we can take the first equation here, and if I clear the fraction, we get xy equals 1. And with the second equation, if I again clear the fraction, then I get xy equals 4. The x and y are repeated, like xy equals 1, xy equals 4. Suggests to me that xy might be part of the transformation. And so based on these two, I'm going to suggest that u equals xy. And if it does, then I can see that xy goes from 1 to 4. And so u goes from 1 to 4. I said a little bit of trial and error. It takes a little bit of practice to get used to the idea that I'm looking for something involving xy to repeat. But my guiding principle there was I basically wanted x and y to be on the same side of the equal sign, which is what I want for the second pair. And there are a couple of different ways we can go. I could say that x over y is equal to 1, and then the analog for the second equation would be that 4x over y is equal to 1. And I've achieved having x and y on the same side, but I have the same constant on the right-hand side. And furthermore, the expressions that involve x and y don't match. X over y, 4x over y. I'd like something that matches like we had in the previous one. So that suggests that I consider y over x is equal to 1, and then y over x is equal to 4. Using those, if we decide that v is y over x, then because y over x goes from 1 to 4, we have that v also goes from 1 to 4. This satisfies the stipulation that we wanted constant limits for u and for v. Please note that our choice of which is u and which is v is arbitrary. We could just as easily have said that v was xy and that u was y over x. In either case, they have constant limits. Now, this is a transformation that takes in x and y and spits out u and v. And in the notation that we see in this section, T inverse is the one that maps regions in the xy plane into regions in the uv plane. In other words, T inverse maps R to S. But what we were asked for was a transformation that maps S onto R. And so what we need is T. And for T, we're looking for X to be a function of U and V, and also Y to be a function of U and V. In other words, we need to solve these equations that we got from the original equations, right? This transformation we need to solve for X and Y. In so doing, we'll be taking points in the UV coordinate system and mapping them into the XY coordinate system. In other words, mapping S onto R. I've rewritten the equations just so they're in front of us. U is xy, and v is y over x. And let's see, I want to have an equation Let's start with I want x is x of uv. So I'm going to isolate y. Y is equal to u over x. And then I'm going to substitute that into the other equation where we have v is equal to y over x. So if v is equal to y over x, then v becomes u over x. It follows that v is equal to u over x squared. So x squared is equal to u over v. And then we have that x is equal to the square root of u over v. Solving that first equation for x will give us that x is equal to u over y. And again, if x is equal to u over y, then v is equal to y squared over u, which means that y squared is equal to uv. And so y is equal to the square root of uv. This is a transformation that takes points in the uv plane into points in the xy plane, and this is the transformation that we're after.